Hi, this is Mr. Ward, and I'm going to do a couple of videos on solving systems of equations by substitution. Your homework, of course, is working through numbers 1 through 19 odd from the CUDA software worksheet that I gave you all in class. So let's start. I'm going to do similar problems. So I've created some similar problems here. This is problem number 4 from the sheet. So it's not one I created. But what we're going to do with this one is we need to substitute some expression for one of the variables. Now, it turns out I've already got y isolated, so that makes my life a lot easier when I'm thinking about what I want to substitute. What I want to do is I want to replace y in the top equation with this expression for y, which is already given to me. Y equals negative 5x minus 17. So copy that equation over, and what I'm going to do instead, I'm going to replace y with this. So I'm going to go down here, parentheses, and in parentheses. So I just replaced y with negative 5x minus 17, and I will simplify that. Negative 3x, then negative 3 times negative 5 is going to be plus 15x, because it's negative 5x there. And then negative 3 times negative 17 will be plus 51 equals 3. Now I'm going to combine like terms. Negative 3x plus 15x will be 12x plus 51 equals 3. I will subtract 51 from both sides. So 12x equals 3 minus 51, which is negative 48. So x equals negative 4. Once I know that x is negative 4, I'm going to substitute that in to this equation. So I'll copy this equation out. I could put the x in here, or I could put the x in here. This one's easier because it's less steps for me to figure out what y is. That's my last piece, is to figure out what y is. So I'm going to replace x. We do not need to know about double chocolate shortbread cookies. Make that go away. Okay, negative 5 times negative 4. So I'm going to end up with negative 5 times negative 4 minus 17. So negative 5 times negative 4 is 20. 20 minus 17 equals 3. So my solution is x equals negative 4, y equals 3. And I express it as an xy point. That is my solution. I'm going to go down and do number 6, which is a similar one. Number 6, again, I have y isolated, so I can replace y in here. So I'm going to copy the equation where I'm plugging it in. I have an expression for y, which I will copy and put in here, substitute for y. And now I have 2 times what y is. Y is 5x minus 7. And I'm going to start simplifying. Negative 3x minus 2 times 5x, so minus 10x. And negative 2 times negative 7, so plus 14 equals negative 12. And now I'm going to combine like terms. Negative 3 and x and negative 10x is negative 13x plus 14 equals negative 12. I'll subtract 14 from both sides. So I get negative 13x equals negative 12 minus 14 is negative 26. I divide both sides by negative 13. X equals negative 26 divided by negative 13, or 2. Once I know that x is 2, I can plug x into here or into here. This is going to be my easier place to plug it in. And I bring that down here, and I replace x with 2, and I end up with 5 times 2 is 10, minus 7 equals 3. So my solution is x is 2, y is 3. Now, sometimes when we do these equations, we end up with some weird situations. So number 13 is a little weird. We have, of course, the issue that our equations don't have anything isolated. So we had to do something about that. But there's another weird thing that's going to show up with this one. I'm actually going to stop the video and start a second one called Weird Stuff.